All right, hello, and this is our week 10 report of the Robotic IoT SmartSpace Testbed. This is a culmination of all the work that we've done the last 10 weeks, and we're excited to share with you. So first, I want to pose to you this question. So how do we create scene inferences from sensor data? This is the big question that we've been tackling these last few weeks. And while most of our work was around building the actual test bed, in the future, we hope to connect our sensors to a large learning model in order to large learning language model in order to be able to understand more from what happens inside of a space. So first, we'll go into some of the details of our project.
So first of all, what is an IoT? IoT stands for Internet of Things. So it's just a collection of devices, a network of multiple devices that communicate with each other, like your thermostat and like your security system in your home. They all work together and talk to each other to do certain tasks.
So we'll begin with a project overview of what we're trying to do. So we're trying to make an IoT test bed out of sensors. And these sensors can detect things like audio, RGB, movement, etc. And what we basically want to do is use the data collected from the sensors to label human activity. So this is things like turning on a light switch, walking around, running, sitting, etc. This will be a predetermined set of activities, and we kind of want to use what the sensors collect and then what the activities are labeled as to create a narrative about the space that the sensors are in. Then we'll also have a website that allows the user to like book the sensors and see if they're online sending data. And hopefully we can later implement a moving robot that allows for mobile sensor data that the user can also interact with.
So in terms of hardware, there's three main components. The first one being the Raspberry Pi Model 3B Plus. This is a microcomputer used to power on our sensors, but also allows us to send sensor data to the database. The second thing that we have is the Maestros, which are our custom multimodal sensors. So basically what this means is that there's 9 different sensors attached, each one responsible capturing different data type in the environment. So this includes temperature, pressure, acceleration, magnetism, and so forth. The last thing that we have is the Raspberry Pi camera module. So this is responsible for capturing continuous video data, which will be used for our automatic labeling for feature extraction and speech recognition in the office space for our sensor data.
Yeah, so as of right now, our website has a coordinate grid where we'll be placing the Maestros in the future. And what we plan to do later is to have these actually be interactive. So it'll show when the Maestros were last activated and when they last had activity. We already have an appointment form, so if anybody decides that they want to use our test bed for their own research purposes, they can go ahead and do that simply by filling out the form. And we also have a calendar that actually live streams what is going on with the Maestros as of the moment, the temperature, RGB, et cetera, et cetera.
So how the database works is we have the Maestros and sensors that are sending data into a server. And you can see in the GIF that it's successfully sending all the data. We can access the data within the database using SQL commands, and we have code on a Jupyter notebook that's on the server. So some of this code controls a web page, which can be used to visualize the data. The picture on there shows audio, but you can also visualize the RGB, temperature, etc. And something we hope to be able to do later is to use a web page to label the data for the machine learning model.
Now, a large thing that we've been working on over a couple of weeks is implementing something called PTP, or Precision Time Protocol. This is a protocol that's able to synchronize the clocks for the computer network, and we need this to be possible in order to have our different sensors and Raspberry Pis to talk to each other very quickly. So what we were able to do was we were able to connect the sensor data to the camera input, which you will see in our poster, and also we were able to send the data to the database in a nanosecond scale. And as you can see in this video, does it work? Yes. So first, we're going to connect to our Ethernet tools, which you should see as a command over here, ETH tools, because we decided that the wireless through the Wi-Fi would be slower. So as you can see, a software transmit shows and it's there. Then we check the status and it says that it's inactive, so we need to start it up. And once we start it, we can be able to see what's happening from the PTP service. You can see over here that once we use this command, it initialized the nodes and it connects to a foreign service which has the clock with the data. And you can see that the packets of data are coming in correctly.
So this is our coordinate system. So if you look in the diagram, the red boxes represent our maestros or our sensors. They're placed in accordance to the outlets in the room for power, but also because of our predetermined activities. So for example, if we wanted to record the sensor data of someone walking in and out of the room, we would place it next to the door.
Some of the things that we're looking for in the future is to implement Unity and robotics to it. So we had a few demos that we developed, including an avatar that mirrors your webcam data so that it's able to, if multiple users are using the testbed at the same time, it will make for a more human-centered design in that more people can be able to see each other and be able to interact. We also created a VR pickup demo, which you can actually try later on during the poster session, which involves a block and some other movable objects in order that you can actually grab stuff that's inside the room. And finally, we also made this first-person camera navigator made from our LiDAR data from a robot in order that you can actually see what's happening in the room using a first-person camera navigator. So as you can see, this person is walking around this room.
And so after that, we also experimented with OpenCV, which is a library for computer vision. So to like take the data that we get and interpret it. So I just messed around with some programs, like this one shows the distance of an object to the camera, and this other one can detect faces and show them on the screen.
Yeah, so for future work, we'd like to implement hardware for PTP because our PTP is simply just software right now. And due to that, it adds some latency. We'd also like to set up the maestros and cameras in the actual room and start collecting data. We'd like to find a purpose for our LiDAR robot and see how we could use that in the future. And then we also want to work on automatic labeling so we can label human activity. And then we'd also like to bridge gap between sensor to text data. And that's it. Thank you.